name is Victor Lee. I'm on Group 4 of Engine Design with a subject called BMA3623. My other group members are Kanchana Saripatri, Chan Weilun, Krishna Lachami, and Dinesh. For the engine that we have selected, the engine is 4AGE, and this engine is mostly found in the Toyota Corolla AE86, which is shown here. This is the front view of the car, the left view, front left, and front right view of the car, as well as the rear views and the side views of the car. So for engine specifications for the 4AGE, basically this engine produces around 80 kilowatts of horsepower at 6,600 RPM and 116 Newton meters of torque at 5,200 RPM. This engine consists of 4 cylinders, which has a total displacement of 1.6 liters, or if you want to be more accurate, it is 1,587 cubic centimeters. In this slide, you can also see the different dimensions for the bore and stroke, the crankshaft, the connecting rod, and the piston pin. That's all from me, and I'll pass it on to my next member. Thank you.
A very good day to everyone. I'm Krishna Lachmi and my metric ID is MH19032. Now, I'm going to explain about the power and torque that we calculated. Firstly, power of the Toyota Corolla AE86 4AGE engine we obtained from the torque multiplied by speed, which in RPM, and divided by 5252 formula. The torque that we obtained from the specification sheet is 109 and the speed in RPM is 5200. The both value we multiplied and divided it by 5252, then we got 108 horsepower. Then we convert it to kilowatt, that multiply by 0.746. Hence, we got 80.5356 kilowatt. Moving to the torque calculation. Torque we obtained from the 6,325 multiplied by power in horsepower and divided by speed in RPM formula. The 6,325 is constant and the power value we got it from the previous calculation. The speed in RPM is 6,600, so 6,325 is multiplied by 108 horsepower and divided by 6,600. From this, we got 1031.32 pound-inch. Then, we convert it to Newton meter, that divided by 8.851. Thus, we get 116.52 Newton meter. That's all from me. Thank you.
Hi, my name is Kanchana Saripatri and my ID is MH19030. So today I'm going to explain the calculation for finding brake specification fuel consumption for an engine. Our engine is 4AGE. So to find brake specific fuel consumption, we have 5 steps. The first step is we have to calculate the area of the piston. So this is the formula. And B here is for the bore measurement. So for 4AGE, our bore is 81 mm. So we include all the measurements inside this formula and we got 0.005153 meter squared. Then we move on to the next step, second step. We calculate the cylinder capacity. This is our formula, and S here is for our stroke measurement. AP is the area of the piston we calculate just now. So for 4AGE engine, stroke measurement is 77 millimeter, and then we include all the measurement into this formula and we got 0.0003968 meter cubic. And then to find the total engine capacity, this is the formula, and NC is for the number of cylinder, and for AGE we have 4 cylinder. Then we include this measurement, the cylinder capacity, we multiply it with 4 and we got 0.00158872 meter cubic. And we convert it into liter, which is we got 1.5872 liter. Move on to the next step. We calculate the engine brake effective torque. To find for the engine brake effective torque, we have to calculate the mean effective pressure first. So here is the formula. Okay, CID here is a multiplication of our displacement engine times with 0.061. So our engine's displacement is 1587 cc multiplied with 0.061 and we got 96.807. Now all the measurement was put inside this formula and we got 151.1006 psi and we convert it into Pascal and this is the value. And then we can find for the engine brake effective torque. This is the formula. And see here is the engine's cylinder, and R is the number of crankshaft rotation for a complete cycle. So for a 4-stroke engine, the NR is 2. So we include all the measurement inside the formula and we got 131.585175 Newton meter. Now, next step is to calculate the engine brake effective power. And here, NE here is the engine speed. And then we multiply it with pi over 30 and the brake effective torque just now we find, and then we multiply it with 1 over 1000, and all of this will result to the engine brake effective power, which is 66.14 kilowatt. Now the last step is to calculate the brake specific fuel consumption. So this is the formula. Fuel mass flow rate divided by just now this brake effective power, and we multiply it with 3600 and we got 130.63 gram per kilowatt per hour. So that's the BSFC 44AGE engine. That's all from me. Thank you.
Good evening. My name is Chan Wei Lun. My matrix number is MH19031. So today I would like to present about energy efficiency. So for this energy efficiency, okay, I'm using the formula of pi times bore squared over 4 times stroke. So in our engine specification, which we are using the engine called 4AGE, which is used in Toyota. So my bore size is 81 millimeter, which is known as 0.081 meter, and the stroke size is 77 millimeter, which is 0.077 meter. Hence, okay, the engine efficiency is we take pi times 0.081 squared over 4 times 0.077, which we get the amount of 0.067, and we times the 100%, which we get 6.70. So we could conclude that the engine 4AGE has an engine efficiency of 6.0%. That's all from me. Thank you.
Hi, my name is Dinesh. My matrix ID is MH19036. So I'm going to continue with the Excel part. So for the Excel part, we just use the software given and key in the specification for our 4AGE engine to generate the values and the graph as well. First of all, the pressure and the volume graph. So the pressure in the air fuel mixture increases when the piston move from the bottom dead center to the top dead center in the compression stroke. So it's moved from here to here, and the pressure reached its peak when the spark ignited the air fuel mixture at the end of the compression stroke. So the peak pressure for our engine is around 86.4295 atmospheric pressure at 55.3 cc, and then the pressure will decrease gradually during the power stroke when the piston move from the top dead center to the bottom dead center. For the next is pressure versus crank angle. So first of all, the top dead center, which is TDC, located here, which is at 0. So to achieve the maximum advantages of high pressure, that generated during the combustion, the peak pressure should be after and near to the TDC. So in this case, the peak pressure for our AGE engine is placed near to the TDC, which is mean that the force generated can be utilized efficiently for our engine. And the peak pressure value for AGE engine is around 86.4295 atmospheric pressure as well at 17 degree from the TDC. The next is fuel deliver versus crank angle. So the graph is generated as below when we key in the specification for our 4AGE engine. So that's all from me. Thank you.